So on page 288, let's just summarize real quick. When we solve using square roots, how many solutions we're going to get. When we did the graphing, it was really easy for us to see how many solutions because it was based on how many x-intercepts we had. If our graph crossed the x-axis twice, we had those two solutions. If it only touched it once, we had one solution. And if it didn't cross it at all, we had no solution. But now we solve using square roots, we still have all three of those situations, but we don't have the visual piece. We don't have the visual, we're just solving an equation. So before we dig in and do the equation solving, let's just spend a minute here talking about how many solutions we're going to come up with. Our very first property we have when d is greater than 0. So if d is greater than 0, what does that mean to us? What kind of numbers are we dealing with? If d is greater than 0, that means we're dealing with positive numbers. If d is greater than 0, we're dealing with positive numbers. So if I end up taking the square root of a positive number, that's when we get two solutions. And notice it says real solutions. For us right now, we're working in the set of real numbers. If and when you choose to take Algebra 2, there is a set of imaginary numbers that allows us to take the square root of numbers. But for right now, for us, we're sticking in the world of real numbers. So yes, we need to be specific. So if we take the square root of a positive number, we end up with two solutions. That's what we saw in our exploration. We have that plus minus. So we could be the positive square root of a number or the negative square root of whatever number we're taking the square root of. Because remember, when we substitute back in, if I take a positive number and I square it, the result's positive. Also, if I take a negative number though, if I take a negative number and square it, I still get a positive result. So that's why we have to include both of those. We need the positive and the negative. And feel free to use a little plus minus. Now, when the number you're taking the square root of, when it equals 0, well, what's the square root of 0? It's just 0. Does it matter if I put a plus or minus in front of it? No, it's still 0. So if we have something where we end up taking the square root of 0, we just get one real solution. We just get 0. Putting a plus or minus in front of it doesn't change it. It's still 0. That's my only solution. Last but not least, if the value we're taking the square root of is less than 0, that means we're looking at negative numbers. And again, for our purposes right now, we have to say there's no real solutions because we can't take the square root of a negative just dealing with the real numbers. Again, there is that set of imaginary numbers. If and when you take Algebra 2, you will get into more of that allow you to symbolize taking the square root of a negative. So for us right now, we have to be specific and say no real solution. We try to take the square root of a negative. Simply because, keep in mind, for example, if I say x squared equals negative 9, if I try to take the square root to solve that, x equals, well, what number squared is going to give me negative 9? What number times itself gives me negative 9? I can't. Because if I try to square 3, I get positive 9. If I try to square negative 3, I still get positive 9. So there's nothing I can square to come up with that negative 9. And even if you try to take it on your calculator, try to do the square root of a negative. I'll pop mine up here real quick. Let's try the square root of negative 9. My calculator tells me right there, it's a non-real answer. Your calculators, depending upon what type you have, it might just plain say error on you. Or it might say non-real answer. I'm not sure. It depends what calculator you are using. So again, you can always use your calculator to double check yourself. So here are three possibilities. square root of a positive number, we're going to have the plus or minus, so positive or negative. Square root of 0, our only solution is going to be 0. Try to take the square root of a negative, we're not going to have any real solutions. So these are our three possibilities. So let's go on to the next page and let's dive into this. Now we touched on this a little bit in the explorations of how we actually solve using those square roots. The biggest thing that I need to stress to you is before you can take the square root, your squared term, so in this case it's an x squared, you have to get it all by itself first before you can take the square root. So you've got to get the squared term by itself on one side of the equation, doesn't matter if it's left or right, before you can take the square root. So in number 1, how are we going to get the 49 to the other side? What has to happen to it? We're going to subtract it. And most of you out there, you're awesome at the steps to solving an equation. Those steps aren't going to change. The only thing we add in now is to finish solving for x, aka to get x by itself, we have to undo squaring it. And to undo squaring it, we take the square root. So if I take the square root of x squared, I get x. What happens when I take the square root of negative 49? Doesn't work so much. Now again, that's something you can even put in your calculator and double check. Because I know I always get people that look at this and they very quickly answer and they throw down negative 7. Be very, very careful. If you need to, pop it in your calculator. So I can't take the square root of a negative. We can't right now. So we say no real solution. I know we're used to when an equation doesn't work out, I know we're used to just putting no solution. But again, there is that set we call imaginary numbers that they do help us take the square root of negative. They are a special set. We're not going to deal with those, but that's the reason why we need to put no real solution. So let's crank things up a notch. Let's look at number 7. Again, you have to get that squared term all by itself first. Now I know we're thinking right away, okay, so that means we're going to move the 49. Yes, we are going to move the 49. And then I get 8x squared equals 200. Now I know at this point you're thinking, oh, okay, so I've got the x squared, it's by itself. Well, if you try to take the square root right now, how does the square root of 8 work out for you? Not so great. So is there one more step we could take before we do the square root? Any ideas out there? How could we move the 8? Divide by it. This is 8 times x squared, so let's move the 8 by dividing by it. Now I get x squared equals 25. Now it's not always going to work out perfect. We're going to see some later on that you're not always going to end up with those awesome perfect squares. But for right now, just starting out, that's an okay thing. I've got the squared term by itself. So to unsquare, we take the square root. X equals, now the number I'm taking the square root of is a positive. So I know if I put that in my calculator, it's only going to tell me the square root of 25 is 5. That's all it's going to tell me. But that's where I have to use my reasoning though and say, well, yeah, it is positive 5. But if I also square negative 5, I get 25. So the calculator can help you find that initial number. But then our reasoning has to kick in. We have to say, wait a minute, that's a positive number. There's 2 solutions there. If I square positive 5, I get 25. If I square negative 5, I also get 25. So you have to slow yourself down. The calculator is not going to give you both. It's not going to give you both, so just be very careful on that. You can write it with the plus minus. For some people, they don't like the plus minus. That's okay. So you can put x equals 5 or x equals negative 5. You can split it apart and write it 2 separate is fine. You can use your plus minus. I don't care which way you do it. The plus minus is how you will see it when you do some of these things in geometry. So I would maybe just get used to that plus minus, but they both mean the same thing. I want to give you guys a chance to go ahead and try out number 12. So for number 12, it has a little bit different look. We've got a constant, and then our x squared comes. Move our 16 to the other side by subtracting it. 16 minus 16, it is 0. It is a 0. On the left-hand side, we have left a negative 2x squared. Let's finish getting the x squared by itself by dividing by negative 2. Here's where we have to be very careful. I know back when we were solving just regular plain old equations that didn't have x squared, they just had plain old x to the first power. Oftentimes I'd have students that they come across 0 divided by something, they see a 0 there, they freak out and they just want to write no solution. I don't know why, I don't know where that comes from, but I see it every year. What's 0 divided by any number?
0.
It's 0. Yeah. So this isn't a no solution situation. I take the square root and I get x equals 0. 0 is an okay solution. That's okay. It's a number. I can have 0. I can have 0 for my x. I can substitute 0 into the equation. So on this page, what we've seen so far, question 1, we had no real solution because we can't take the square root of a negative. Number 7, we took the square root of a positive number. So we had two solutions, positive and negative 5. And then in number 12, we ended up taking the square root of 0, so we just had one solution, which was 0. So we've seen all three different cases now. So now, cranking things up just a little bit, we look at number 15. Now, I usually get people in number 15 that tell me, wait a minute, Miss Golly, but there's just an x to the first power there, so you said we can't do that with square roots. I do have one x. But is that x really to the first power, or is it being squared? It is being squared. That x is inside the set of parentheses. That is being squared. So I do only have one x, but it's part of the squared term. It's part of the squared term. So now I know we're all very, very tempted to try to distribute that little squared. But remember, what does it mean to square something? It means that whole thing times itself. So we'd have to do 2x plus 7 times the quantity 2x plus 7 and do FOIL or box or all that stuff, and that gets really messy, and you know what? It's not going to help us. Right now, my squared term is what's inside those parentheses. That whole thing is being squared. So to undo squaring something, we take the square root. Now I know it looks a little bit different because it's not just an x squared I'm taking the square root of, but everything on that left side is being squared. Everything in that set of parentheses is being squared. So to undo the squared, take the square root. Now when I take the square root of the left side, the square root just takes care of the squared. Nothing else changes. The square root just takes care of the squared. Nothing else changes. Now on the right-hand side, though, we're taking the square root of 49. We're taking the square root of a positive number. So what are my possibilities for the square root of 49? 7 or negative 7. I just took the square root of a positive number. So I have two possibilities. It could be positive 7, it could be negative 7. Now if you think, Miss Golly, how are we ever going to solve that? How are we ever going to solve that? I've got that plus minus thing. I'm not real sure about that. So let's break apart that plus minus into what it means. So let's split this apart. So we have 2x plus 7 could equal positive 7. 2x plus 7 could equal negative 7. Just split it apart into its positive and its negative. We should have two solutions, so now we've just split it apart. so we can find each one. From here, you just solve equations like you know how. The nice thing is, all the steps are the same. All the steps are the same. We're going to subtract 7, and we're going to divide by 2. Now, usually when I write my answer, I usually put the word or between them. Oftentimes, you will also see there'll just be a comma between them, and that's okay. But it's the same thing we saw when we were graphing. It's not an ordered pair of 0, negative 7. It's x equals 0, x equals negative 7. You can write it either way. When I learned this, I learned to put an or between them. Your textbook puts the comma. I'm okay either way. I don't care which way you guys write it. Just keep in mind that x equals both. Let's try out one more of these before we get into some that they don't work out perfect for us. We don't get nice square root of 49 and square root of 25. Let's try one more before we move into some where we will have to do some estimating. Let's look at number 16. Now, number 16 looks a lot like 15. My squared term is actually everything going on inside these parentheses. X minus 3 is being squared. Now remember, I know it's very tempting to try to just square the x and square the 3. But remember, this really means x minus 3 times x minus 3. You have to do the whole FOIL, box, double distribute, whatever you want to do, and you just get a big mess. So just be very careful. I'm not going to try to distribute that squared. Just be very, very careful on that. But before I can take the square root, though, like I did in number 15, what do you think we need to do first? Now, I know some of you right now are thinking, oh, Miss Callie, we got to distribute that 16. Why can't I distribute that 16? Why can't I distribute that 16? It's in front of a set of parentheses. Why can't I distribute it? Because the parentheses, they have an exponent. So I can't just distribute this 16. I'd have to do my exponent first. And to do my exponent first would mean this whole messy thing. And then I could distribute the 16. If there wasn't a squared there, yeah, distribute the 16 and solve away. But I cannot distribute the 16 because that set of parentheses is being squared. So I can't distribute the 16. What else could I do with it? What do you guys think? This means 16 times this whole mess. How do I undo multiplying by 16? Divide by it. Divide by it. So we need to get that squared term by itself. Now I know some of you right now are busy putting 25 divided by 16 in your calculator and getting 1.5625. Ugliness. Take a look at 25 and 16. Those are both perfect squares. My next step to solving this is going to be to take the square root. That's what we have to start anticipating a little bit. I'm going to be solving using square roots. You should have that game plan down as you're solving. You're thinking, well, one of my last steps, I'm going to end up taking the square root. Well, if you've got a couple perfect squares sitting over here, make a little less work for yourself. Square root of 25 is 5. Square root of 16 is 4. Make a little less work for yourself. Granted, yes, you could put that in the calculator and you would get your 1.25. But this is even quicker. This is even quicker. So now when we go to finish solving, we are going to add our 3 over. And yes, it turns into, and don't worry, we're not going to do 17, so if you need the space, use it. X equals, and you end up with your positive 3 plus or minus 5/4. So if you want to write it as 1 1/4 or 1.25, whatever you like. So remember what that plus minus means. 3 plus 1 1/4, 3 minus 1 1/4. Split apart that plus minus. You do have to split it apart and actually finish solving it. So we end up with 4 1/4 and negative 1 3/4. So I know that plus minus, I know it takes some getting used to, but you have to finish out your answer all the way. You have to finish it out all the way. Should be positive 1 3/4, guys, not negative. So far, everything has worked out perfect for us. Whether we had one solution, two solutions, we always ended up with perfect squares. 25, 16, 49. Every time we took the square root, we got a really nice number to work with. Unfortunately, that doesn't always happen. So I just want to finish up with a couple today that they don't work out perfect for us. Let's take a look at 21. How we solve, same thing. We're going to subtract the 25. We need to get that squared term by itself. So x squared equals 24. If I take the square root of 24, I'm not going to get a nice number like 5 or 7 like we were getting earlier. When we take the square root, I know the directions say to round to the nearest hundredth, but what I want to do is take this opportunity to give you a chance to refresh yourselves on all that time we spent in section 9.1 actually simplifying that radical. So what I'd like you to do for me before you jump to the calculator is I would like you to simplify that square root of 24. So for most of you that means you're going to break it down and you're going to make pairs. So let's see what we remember, a nice little refresher from 9.1 for us. So start breaking down. I'll start breaking it down up here. I know a lot of you like to make pairs instead of looking for the perfect squares. That's okay. If you want to make a tree, go ahead and make a tree. I have mine simplified up here. Check yours with mine. The thing we have to be careful of, yep, we simplified. I know most of you broke it down and made pairs. But keep in mind, we did still just take the square root of a positive number. So we still need the plus minus. We did just take the square root of a positive number, so we still have two solutions. This, ladies and gentlemen, this is an exact solution. So if you are asked to give an exact solution, that is what you're being asked for. If you're asked to round, you still need the plus or minus, and then that's when we grab the calculator and it says to round to the nearest hundredth. So approximately 4.90. So this is rounded, or if it asks you to approximate, that's what we're looking for. If you're asked to round or approximate, you do need that little squiggly equal sign. That means approximately. It shows that, yes, you have rounded your answer. It shows that you have rounded your answer. I just wanted to finish up with one more that doesn't work out quite so perfect. Just, again, to give us a chance to refresh on a little bit of what we did at the very first section of this chapter. Let's move our 5. 6x squared equals 15. Divide by our 6. X squared equals... And let's go ahead and just simplify the fraction. Don't give me a decimal. Simplify the fraction. 3 goes into 15 and 6 5 times and 2 times. So we end up with 5 halves. So we end up with 5 halves. Now when we take the square root, I end up with a radical in the denominator. Now writing it as 2.5, it doesn't help us fix this problem. Or 2.5, it doesn't help us fix the problem. I wanted to give us a chance to refresh on, and that's what I'm going to process through, of how to rationalize the denominator. Again, this is from our very first section from 9.1. We can't have a square root in our denominator. So in order to get rid of that, we multiply numerator and denominator by whatever radical we need to get rid of. So if it's the square root of 2, I multiply by square root of 2. Or if it's a square root of 3, whatever the case may be. Because when that happens, if I take the square root of 2 times the square root of 2, that gives me the square root of 4. 4 is a perfect square, so it simplifies to a 2 for me. Another nice refresher opportunity for us happens up in the numerator. The 5 and the 2 are both inside those radicals, so I can make that the square root of 10. I no longer have a radical in my denominator. I'm all set. The only thing I have to stop, though, and remember is I just took the square root of a positive number. I need the plus minus. I can't forget the plus minus piece. So that would be an exact solution. And then we have an approximate solution, plus or minus 1.58. So again, if you're asked for an exact solution, you might have to use your skills from section 9.1. If you're simply asked to just round, then that's when your calculator comes in handy, if you're just asked to round. Now I know there's a couple application questions on here. I just want to touch on those real quick. Number 25, a ball being dropped, that's something we saw a bunch in chapter 7 and chapter 8, and now here it is again in chapter 9. And we've attacked it many different ways. We've factored and solved, we've graphed and solved. But now what we can do, it's asking us, how long does it take for the ball to hit the ground? So if I hit the ground, that means I have a height of 0. And now instead of worrying about trying to factor it or trying to graph it or to try to make a table of values for it, take a look. All I have is an x squared term. I don't have a plain old x in there. So I could solve this using square roots. I know, again, back in chapter 7, we did some things with greatest common factor to solve something like this. Last chapter, we did some graphing to solve something like that. But now we could solve using square roots. So I just wanted to throw that out there. We're not going to finish it off. We don't have time today. But just to give you that idea, that's how you could solve something like that now. We now have that as one of our skills. Last but not least, 26. I just want to go through this piece with you of how to solve it for R. Solving a formula or an equation for a variable is something that we haven't done in a while. So if you want to get R by itself, we've got to move the 1/3, we've got to move the pi, we've got to move the h. We've got a lot of stuff going on. Let's start with the 1/3. I have 1/3 times all that stuff. How do I undo multiplying by a third? I know we're going to say divide by a third, and then things are going to get messy. So dividing by a fraction is the same as multiplying by its reciprocal. So dividing by a fraction, same as multiplying by its reciprocal. So we get 3 times capital V we get pi r squared h. This is pi times r squared, and then it's also times h. To undo multiplying, we can divide. And we can divide by the pi and the h at the same time. That's okay. I know solving for a variable, I know it's something you did a bunch last year. If you're taking geometry, you might also be doing it in there. I'm not sure where you guys are at with that. But you can divide by both of those at the same time. So 3 times capital V divided by pi h equals r squared. To undo squaring r, we take the square root of both sides. So 3 times capital V divided by pi times h, the square root of that, will equal r. Now I don't need a plus or minus on there because we're trying to find the radius. The radius doesn't make sense for me to have a negative number because it's a measurement. So I don't need the plus minus. I don't need the plus minus. So I know that one. I know it was pretty quick, but at least just want to give you an idea of when it says to solve for the variable, you're not just throwing numbers in there right away. You're actually playing around with that formula to get that variable by itself. And again, I know it's something you did a bunch last year. You do have some in the practice, so if you come across problems, guys, just let me know. I know that was kind of a quick little review of that.